This example is simply a summary of the exponent rules that we have covered so far in this book. There are 3 rules for multiplication. The first says if you're multiplying the same base, you can add the exponents. The second says if you have an exponential expression in parentheses raised to another exponent outside the parentheses, you can multiply the exponents. And the third says if you have a product inside parentheses raised to a power, you can apply that power to each factor inside the parentheses. Then there are 3 rules for division. The first rule for division is the counterpart for the first rule for multiplication. When we were multiplying, we added the exponents, so when we're dividing the same base, we can subtract the exponents. The second division rule says if we have a fraction in parentheses raised to a power, we can apply that power to both the numerator and denominator. That is the counterpart for the third multiplication rule. And the third division rule says a to the 0 equals 1. It is important to recognize for all 3 of these division rules, we cannot have 0 in the denominator of any fraction. So for the first rule, a could not be 0 because we'd have 0 in the denominator. For the second rule, b could not be 0 because we'd have 0 in the denominator. And in the third division rule, rule 6 by what we have on the paper, we cannot evaluate 0 to the 0 and call it equal to 1. We also have 3 rules for negative exponents. The first says a negative exponent really means 1 over that expression without the negative exponent. So a to the negative n is 1 over a to the positive n. The second negative exponent rule is really a restatement of the first one. 1 over a to the negative n equals a to the positive n. One way to summarize both of those 2 rules into one statement is a negative exponent means this expression belongs on the opposite side of the fraction. Things in the numerator go to the denominator, and factors in the denominator go to the numerator. The third negative exponent rule, rule number 9 on our paper, is really a combination of both rule number 5 and rule number 7 and 8. Rules number 7 and 8 say what's in the numerator should end up in the denominator, and what's in the denominator should end up in the numerator if you have a negative exponent. And rule 5 says you can also apply that exponent to both the numerator and denominator. So you can see what we go from in the beginning of rule 9, the quantity a over b to the negative nth power, and to our final answer, b to the n over a to the n. The fraction has been flipped upside down, taking care of the negative, and the exponent has been applied to both the numerator and denominator. And then we have 3 rules for rational exponents. The first rule for rational exponents is that a 1 over n exponent means the nth root of something. The other 2 rules, a to the m over n being the nth root of a to the m, or a to the m over n being the nth root of a then raised to the mth power, are both equivalent statements. You simply will choose to use one version over the other depending on your context. Typically, when you're working with variables, you would choose rule 11. And typically when you're working with numbers, you would choose to start with rule 12. Rules 11 and 12 are equivalent, it just depends on the context which one you would want to work with. Please note, at Portland Community College, most instructors at this level course will expect you to have these rules memorized, that you will need to demonstrate your understanding and your ability to work with these and your knowledge of these rules without any notes or other assistance during an exam situation.